Hi students, in this session let us learn what is H-plane T junction and how to determine the S matrix, scattering matrix for H-plane T. Okay, so here this is the geometrical representation of H-plane T. Okay, here the number of ports for H-plane T is 3. Port 1, port 1, port 2 and port 3. Okay, port 1, port 2 and port 3. Here port 1 and port 2 are the collinear arms, where the port 3 is named as side arm or HR. Here the port 3 side arm or a H arm which is in parallel to the collinear arms, so that the H plane is also called as shunt T. Then the name for H plane T is shunt T. Now you have to determine the S matrix for H plane T. So to determine S matrix, scattering matrix for any T junction, so first thing you have to know the properties of that particular T, properties of that particular T junction. And one more thing, you have to know the properties of S matrix. Okay, so if you know these two things, these two properties, you can derive the S matrix for any type of T junction is very easily. Okay, now start with properties of H plane T. So here coming to the H plane T, it is of how many ports? It having 3 ports. 3 ports, so that the order of that scattering matrix is 3 into 3. Okay, so it means the scattering matrix consists of 9 elements. 9 elements are S11, S12 and S13. This is the first row. S21, S22 and S23 is a second row. S31, S32 and S33 is the third row. So these are the 9 elements. We have to determine these 9 elements. Okay, so here coming to the H plane, if the input wave is incident at H arm. H arm means it is port 3. So here the port 3 is perfectly matched. Okay, perfectly matched. If it is perfectly matched, what will happen? There is no reflections. These no reflections can be represented in scattering elements like, so now I am incidenting wave into port 3. This is my input port. There is no reflections to the same port. That is also my port 3. Okay, so that there is no reflection, there is no signal out from the port 3 is, it can be represented as S33 equals to 0. Okay, this is one important point regarding H plane T. And similarly, another one is for H plane T, if input is incident in port 3, okay, or the power at port 3 is equally divided divided at port 1 and 2. Okay, whatever the power incident at port 3 is equally divided at port 1 and port 2, and along with this having in phase. Okay, having in phase. Now this can be represented in scattering parameters. Okay, now I am incidenting wave into port 3. Okay, this represents input, and now it is coming out from the port 1. Okay, so now it can be represented with 1. So this represents output port. Okay, and similarly same signal incident at port 3 and it is coming out from port 2, and according to this what happens, the power is equally divided and having same phase. Same phase, in phase means the sign should be same and equally divided. We can write it as S13 equals to S23. These are the two important things can be obtained from the properties of H plane T. Okay, now let's go with the properties of S matrix. Okay, coming to S matrix property, the first property is symmetry. Okay, according to the symmetry, what you can write, S12 equals to S21, S13 equals to S31, and next S23 equals to S32 S32, S anything else, S3. Okay, this is okay. So these are the scattering parameters can be equated depending upon the symmetric property of scattering matrix. Okay, now let's go with another property. What is the another property? Unitary. Okay, unitary matrix property. Unitary matrix property, what is meant by unitary matrix property? The unitary matrix property is nothing but unitary matrix property. So the unitary matrix property is nothing but product of S matrix with its complex conjugative is equal to identity matrix. Okay, now first, by considering properties of H plane T, we get two conclusions: S33 equals to 0, S33 equals to 0, and S13 equals to S23. Okay, and you can replace these values in a scattering matrix along with the symmetric properties. So a new matrix will be obtained, and then you can do the unit matrix operation and equate it to identity matrix. Okay, what is the new matrix now? The new matrix is S11, S12. First row is S11, S12, S13, S12, S22, S13, 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 and 0. Okay, now we start doing product of scattering matrix and its conjugative is equals to identity matrix. Okay, here we have to take the identity matrix is also a square matrix of 3 by 3. So S11, S12, S13, S12, S22, S13, 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 0. And its respect to complex conjugate to S11 star, S12 star, S13 star, S12 star, S22 star, S13 star, S13 star, S13 star, 0. Okay, which is equivalent to identity matrix 1 0 0 0 1 0 0 0 1. Okay, now you can do the row and column multiplications and equate to respect to either 1 or 0. So depending upon the equations you can do it, and then you get the equations. First let us do the multiplication of R1 and C1. Okay, R1 and C1, which gives S11 S11 star plus S12 S12 star plus S13 into S13 star. Okay, which is equals to 1. So if you take the modulus, okay, absolute value of that scattering parameters, so that you can write it as modulus of S11 square plus modulus of S12 square plus modulus of S13 square. Okay, equals to 1. Let us assume this is equation 1. And similarly we can do for R2 and C2. Similarly we get the same expressions like S12, S12. Okay, S12. What is S12? S12 modulus square plus S22 modulus square plus S13 modulus square equal to equation 2. Okay, now we have to do for row 3 and column 3, which gives S13 modulus square plus S13 modulus square equals to 1. So this is equation 3. Okay, now concluding equation 3, you can write it as 2S13 modulus square equal to 1. So it is nothing but S13 is equal to 1 by root 2. Okay, so we get one more element, one more parameter in S matrix. And next, now compare equation 1 and 2. What will happen by comparing equation 1 and 2? What will happen? Here we having S11 square. Okay, here we having S12 square. And see, in equation 1 and 2 we having S12 square here, here S12 square, S13 square here, S13 square. But the difference in both the equations is, in equation 1 we having S11 square, in equation 2 we having S22 square. So this means that, so remaining elements are same, only these two elements are different. So that you can write it as, what we have to write? We have to write it as S11 square is equals to S22 square. Okay, that's it. So this means that S11 equals to S22. Okay, next coming to, let us do one more row and column multiplication, which is R3 and C1. R3 and C1, which gives S113 modulus S13 S11 plus S13 modulus S12, okay, equal to 0. Okay, now from equation 1 and 2 we conclude that S11 equals to S22. Now coming to the equation 3, we already determined it. What is from equation 3, what we conclude, S13 equals to 1 by root 2. Okay, now you can replace S13 equals to 1 by root 2, which gives 1 by root 2 of S11 plus S11 star plus S12 star. So here what will happen, here S11 S13 is taken as a common, and where S13 equals to 1 by root 2. Okay, now so you can conclude it as, so if any two factors becoming 0 by doing multiplication means any one of the factor becomes 0, or both the factors should be 0. Okay, so 1 by root 2 should not be equal to 0. So it means that S11 plus complex conjugate of S12 star is equal to 0. You can write it as S11 star equals to minus S12 star. So if you apply the complex conjugate again, you are getting S11 equals to minus S12. Okay, so this is one more conclusion, S11 equals to minus S12. Okay, now let us take the equation 1. In equation 1, let us see what is that. The equation 1 is S11 square plus S12 square plus S13 square. You can write it here. S11 square plus S12 square plus S13 square, okay, equal to 1. Already we know that S13 equals to 1 by root 2, okay, whole square, plus what is S12? S12 equals to minus S11, or S11 equals to minus S12. So in modulus and doing square it will be same, so that you can write it as S11 square plus S11 square. Okay, finally 2S11 square plus 1 by 2 equals to 1. So 2S11 square equals to 1 minus 1 by 2 gives 1 by 2. So finally S11 square equals to 1 by 4. That implies S11 equals to 1 by 2. Okay, we get one more value. And if S11 equals to 1 by 2, then what will happen? What about S12 value? So S12 equals to minus 1 by 2. Okay, so if S11 equals to 1 by 2, that means that S12 equals to minus 1 by 2. Okay, from this we got all the elements in S matrix of H plane T. Now you can replace all the element values in this matrix, and let's see how it looks. So the S matrix for H plane is S11 equals to 1 by 2, S12 equals to minus 1 by 2, S13 equals to 1 by root 2, and again minus 1 by 2, 1 by 2 and 1 by root 2, minus 1 by 2, 1 by root 2 and 0. So this is our matrix. Now in generally it can be represented in terms of input ports and output ports. Is output port equals to S matrix, output matrix is equals to S matrix into input port matrix. So here you can write it as input port is A11, A11, A12 and A1, A2 and A3. Okay. So output ports B1, B2 and B3. Okay. Now what about the scattering matrix? So already we determined. So you can put it this here. 1 by 2 minus 1 by 2, 1 by root 2. Minus 1 by 2, 1 by 2, 1 by root 2. And next minus 1 by 2, 1 by root 2 and 0. Okay. Now you have to write the respective equations for output equations by using the scattering matrix. Okay. So B1 equals to what is B1? B1 equals to A1 by 2 minus A2 by 2 plus A3 by root 2. And what about B2? B2 equals to minus A1 by 2 plus A2 by 2 plus A3 by root 2. And what about B3? B3 equals to minus A1 by 2 plus A2 by root 2. Okay. So now let us take some different cases and how whether we defined a H-plane T. Already we defined H-plane T where if you apply input to port 3, then the power is equally divided. Power is equally divided at port 1 and port 2 within phase. Whether this statement is correct or not by considering some cases, let us see. Okay, let us see. Okay, now I'm taking a case that in case 1 I'm taking, so I'm applying input to port 3. Okay, so port 3 means here the port 3 which is represented with input A3, it should not equals to 0. And I'm not applying any input to port 1 and port 2. It means port 1 equals to port 2 equals to 0. Now substitute these values in B1, B2 and B3. Then you get B1 equals to A3 by root 2. B2 equals to A3 by root 2. And B3 equals to 0. Okay. From this what we conclude that, so here the B1 which represents the port 1, B2 which represents the port 2. So according to the statement, the power is equally divided to port 1 and port 2. So from this it will be satisfied. So the power at port 1 and port 2 is same, which is indicated by A3 by root 2, A3 by root 2. What about the port 3? So here the H-plane, the port 3 is perfectly matched. Perfectly matched. So perfectly matched port 3. So at port 3 the power is 0. So the H-plane T junction definition is satisfied here. Okay. Let's go with one more condition as case 2. So in case 2, let us assume we are applying inputs to only port 1 and port 2 and which is equal to same input. That is, let us assume it is A. And there is no input is applied to port 3, that is 0. Now what will happen? Now you have to determine B1, B2 and B3, corresponding B1, B2 and B3. So B1 equals to, what will happen? A by 2 minus A by 2 gives 0. And B2 equals to minus A by 2 plus A by 2 which gives 0. And coming to B3 which equals to A of 1 by root 2 plus 1 by root 2. Okay, which indicates that 2A by root 2, which indicates root 2A. So if you apply the same inputs to port 1 and port 2, okay, then what will happen? So the power should be added. Port 1, port 2 power is added and it is propagated to port 3. Okay, from this statement, if if the input is applied it to port 1 and port 2, same input is applied it, so the power will be propagated through port 3, and the power which is summation of at port 1 and port 2, okay, which is nothing but root 2a. Okay, so this is about the H plane T junction and how to derive the scattering matrix for H plane T junction. So if you like, please like, share and subscribe for this channel to get more derivations, explanations in easy way. Okay, thank you.